everyone. I'm very happy to be here. Did you enjoy KubeCon so far? Oh, okay. I did enjoy KubeCon a lot last night. It was really good. And yeah, this KubeCon is very special to me. I want to thank CNCF for putting this together. After 4 years of working with Sanskar on Flagger, on Flux, sometimes day and night. He is from India, I'm from Romania, Bucharest. There is some overlap between us, but we managed to do it. This is the first time ever we met in person, so yay! Yeah, so today we are going to talk about Flux ecosystem, the tools around Flux. Don't worry, we are going to talk about Flux a little bit at the end with the roadmap and everything, but this session is focused around the tooling we've built around Flux to extend it, to enrich the way you do GitOps. And the first, there are two major projects in the Flux CD organization. There is the Flux project in its current form, version 2, is the, the continuous delivery tool powered by GitOps Toolkit. You know all of that, that's why you're here. So I'm not going to insist that much on this. And there is also Flagger. It is a sub-project inside the organization, but it can be used independently. It's a standalone tool. It has been developed for, I don't know, 6 years?
Yeah. More than that, 7 almost.
7, okay. 7 years. It's something that's like an add-on to Flux if you mix it together, but as I said, works with any other tool out there that can do continuous delivery. And it helps you at the end of the road of everything that happens in your pipeline. So you can think of Flagger as the thing that in your production system is right there before your users get to interact with the new version of your app, and tries really hard to, protect you from mistakes. It does things like automatically rollback. It can, shift traffic from one side to the other. It implements a lot of deployment strategies that Kubernetes itself is not capable of, the Kubernetes deployment controller. So you can think about if Flux is an extension of Kubernetes API in terms of watching the external world, being a Git repository or a container registry or even an S3 bucket or a Helm chart in a container registry. So Flux does that, watches the outside world, then it brings all those changes inside the cluster. If those changes would have been automatically deployed to all your users and you had the problem in there, you will be affecting everyone, right? So Flagger solves this part where, let's say in this workflow, Flux scans the container registry, sees, oh, there is a new version of an application. Let me go into Git and update the image tag from version 1 to version 2. And so this is step 1, what Flux image automation does. It just commits to Git. And you can run Flux image automation on, not in your production cluster. You can run it outside, and you should be running it outside. It's like a dependabot, if you want, for Kubernetes workloads. Then the other part of Flux is, hey, there is a change in the desired state. Now I need to deploy a new version. So it applies that change on the cluster. Then Flagger, if you've set up Flagger on the cluster, it will say, oh, you want to deploy a new version. I'm not going to let the Kubernetes deployment controller kick off. I'm going to take over. And based on a policy, it's a canary custom resource. Sanskar will show you that later on. Based on that policy, Flagger will start to shift traffic a little bit towards the new version. test it out with metrics and so on. And at the end of that analysis, it says, okay, according to your defined SLOs, the new version is good. Now I'm going to roll out to the whole user base, and that's how the deployment ends. So basically, Flagger, it disconnects continuous deployment from the actual release, right? If with a continuous delivery tool like Flux, you continuously deploy changes, Flagger does it in a disconnected way where releasing becomes something else. And releasing means doing it progressively, doing it with guardrails, so your users are less affected by mistakes. Now, we have this in place now with Flux and Flagger, and Sanskar will talk about Flagger. After that, I'm going to demo Flagger for you today. After that, I'm going to talk about another ecosystem tool called Flux Operator, which acts at the CI level up there. When you do a commit change, you open a pull request with that change, and maybe you don't want to end up in production to actually see that whatever is happening on the Kubernetes cluster is not that good. And basically, Flux Operator can watch pull requests, watch the registry, and create for you ephemeral environments where you can actually test the thing before you merge it. But as always, it doesn't matter how much testing we are doing on our testing environment, staging environment, there is always the chance we are going to break production. So Flagger is a core part of that, and Sanskar, please go ahead.
Right. So just a quick show of hands. How many of you are actively using Flagger in your Kubernetes clusters? Okay, I see a few hands. So there is some bunch of exciting stuff that happened over the last few months. We were the first ones to add support for Gateway API, and in true fashion in that, we added support for AWS Gateway API as well. And there are a bunch of other things that we did. You can see them on the screen, but there are two main things that we're really excited to introduce here. One is support for Knative. Knative has been on our roadmap for a very long time. A lot of users love Knative because of their whole serverless architecture. And integrating with Knative is a challenge because they have their own deployment model, right? They don't use they use Kubernetes deployments, but they have their own layer around it. So it was a bit of a challenge to get there, but we managed to do it. And the way it works is actually a bit different than how other networking technologies work. So if you were to use this with, let's say, Gateway API, you would define some networking object like a route or something which kind of split HTTP traffic. Here, instead of targeting the Kubernetes deployment, you target the Knative service itself. And it's actually very easy to get started. You deploy a Knative service, and then you create this canary object, and then you're off to the races. By the way, this was a community contributed feature, so a big shout out to the community for contributing this feature. And there is one more thing which I would like to talk about, and it's a sort of a problem. But before we dive into the problem, I wanted to explain how we do progressive delivery today. So if you think about it, it's pretty simple, right? You have a primary workload and a canary workload. In this diagram, the blue one is the primary one and the green one is the canary. So what you do is you slowly start shifting traffic towards the green one. So first at 5%, then at 10%, and then until you're satisfied that the new version is working perfectly fine, it's all good, you keep shifting traffic, and then you start directing all of your traffic to the green deployment. So Flagger does all of this for you. It automates it fully. It can hook into Prometheus, a bunch of other metric providers. It fully automates this for you. But one asterisk here is that the weights are actually random. As in, you can't define which user gets routed to what deployment. So if we apply that analogy to this next slide, so on the left-hand side, it's the old Spotify UI, and the right-hand one, this I pulled off Google, and the right-hand one is a screenshot of my Spotify application. So if you think about it, if the team were to apply progressive delivery to this scenario, a user would first get directed to the left-hand side UI, which is the old one, right? And then during the during the life cycle of a canary analysis, they would end up seeing the right-hand side, but then they would also switch back to the left-hand side because traffic distribution is random. You can't really control who sees what. That's a big problem. Like, you don't want users to have an inconsistent user experience. You want them to have a consistent user experience where they are comfortable with what they're seeing. So, but how do we solve this, right? So we came up with a new sort of deployment strategy which combines weighted routing with session affinity. So session affinity is nothing new. It's been well established. We know that if we want users to continuously hit a particular workload or particular service, you use session affinity, which introduces stickiness, right? So what we thought of was, what if we combine weighted traffic routing with session affinity, so that you still get the benefit of slowly shifting traffic from your current deployment to your new deployment, so that you don't affect all your users all at once. But if a user is served by the canary workload, which is the new version, they're always served by the canary workload. So once they see the right-hand side UI, they will never see the left-hand side UI. And that's the kind of the user experience you want to offer to the users, right? So I'm going to quickly demo this, and I hope the demo gods are with me today. Okay. So, thank you. Let me know if this font is visible. Okay. So here I have a canary object already defined in a Kubernetes cluster. There is a bunch of stuff which we can gloss over, but one thing I really want to highlight here is this particular section here, which defines the cookie name. Yeah, so this cookie name is what Flagger will inject into the responses served by the canary workload. And that's how you actually do the stickiness thing. And Flagger fully automates this. All you need to define is a cookie name, and Flagger will generate random cookie values during the life cycle of a canary analysis. And here we can see that we are targeting this pod info deployment, which is our target workload. So let's see it in action, right? So I have a Istio ingress gateway API set up already on this Kubernetes cluster. And what I'm going to do is I'm actually running 6.0.0, as you can see here. And I'm going to go ahead and set it to 6.0.1. So basically trigger a canary rollout, right? And I'm going to wait for Flagger to do its magic. So what's happening behind the scenes is Flagger is configuring the HTTP route with the correct response headers and the cookies and everything to make sure that the session affinity takes place. So right now it's scaling up the canary workload, which is running the new version, that is 6.0.1. So let's just wait while it does that. And I'm going to go ahead and, so I have two incognito tabs here to display the cookie stuff, because cookies can get weird if you have the same tab. So I'm going to go ahead and load it up here and here as well. Okay, so as you can see here, it's both of them are were being served by the primary or initially, but now they're being served by the canary. And now if I try to reload this, it always hits the canary. Even though if you were to inspect the HTTP route, a lot of the traffic distribution is towards the primary workload. But yet because this window and this window as well hit the canary workload, hit the canary workload, it always hits the canary workload. You always get served by the new version. And this is kind of the behavior we want users to experience.
Yeah, so the trick here was we want to, progressively move traffic from one side to another, but we don't want users to jump back. So yeah, it was quite challenging because now we have two types of injecting cookies. We inject cookies on a canary, and you give it a name, then Flagger, you set it random, but it's not random, generates a unique cookie name for each canary session. So every time you start a new deployment, everything starts from 0, and then that's how we can pin users to particular versions. And in the last addition in Flagger, we also create a cookie for the primary, so we can do fine-grained load balancing between the two. Yeah, this is something Sanskar was working a lot on. This works with Gateway API. It works with Istio and other ingresses, correctly?
Yep, anything which supports Gateway API works with that, and if you use Istio virtual services, works with that as well.
Yeah, I am extremely happy about Gateway API. When we started Flagger, we had to integrate every single API, like Istio API, Solo.io API. There are so many out there, Ingress. Yeah, and Gateway API basically unifies all the way you can define networking. If there is tomorrow a new service mesh or a new Ingress or a new CNI out there that plays the service mesh role, we don't need to change Flagger anymore. So that was a great win for the cloud native community, having this type of API that simplifies how other tools can program traffic, because this is what Flagger in a way is a traffic programmer. It programs the traffic, but it also interacts with metrics and so on. Thank you very much for the demo. Give it a clap to Sanskar. So okay, what else we have in the Flux ecosystem? I want to give a major shout out to the Headlamp team. They've been working on, I think it's 1 year now. They've been working on this Flux plugin for Headlamp. If you don't know what Headlamp is, it's a Kubernetes dashboard. It used to be a sandbox project, but they announced at this KubeCon they are moving under Kubernetes SIG. So they are now part of the Kubernetes project under SIG UI, which tells that, Headlamp is successful, the community is growing, they are improving day by day the Flux plugin. Recently they released an overview page for Flux. I've also seen in beta a Flagger integration in this dashboard, so you can actually see canaries moving and so on. My request to you is, if you are a Flux user, maybe like me, you don't use UIs, it's okay. Give this a try. Bring back feedback to the Headlamp team. They'll definitely appreciate it. So yeah, there is a link there. Go and read their blog post. And yeah.
If any of you catch the keynote today morning, they demoed Headlamp with Flux as well. So that means it's here to stay, and the integration is pretty strong.
Yeah, cool. Okay, so how much time do I have?
You have 12 minutes.
5 minutes?
12 minutes.
12 minutes, okay, plenty of time. Okay, so I'm going to say a little bit about my pet project in the last year. It's called Flux Operator. We've been building this for, I think 1 year. It's me and other Flux maintainers under ControlPlane. It's an open source project. And we started this adventure by, the desire of OpenShift users to be able to use Flux in an OpenShift native way. So okay, I said, okay, I'm going to create an operator, even if I was like, why are we creating an operator when Flux is already an operator? It was like, okay. So yeah, we created Flux Operator. The first goal of this was to list it on the operators hub. So, it fully integrates with OpenShift ecosystem. You do ClickOps, you click there and you install it, or I don't know, you can configure it with a subscription. And that's how we started. So before the Flux Operator, how people were deploying and bootstrapping Flux was with the Flux CLI or with the Terraform provider. So we had to come up with a new abstraction for, allowing a declarative model for bootstrapping Flux. And after we released it, we realized that many other users were like, I'm not running on OpenShift, but I like this idea. I want to switch to it. So it kind of grew from there. And we ended up in a place where Flux Operator streamlines how you can deploy Flux on hundreds of clusters, is how you can optimize Flux. It's very easy to do sharding. All the advanced configurations that you think of Flux, you can do it with the Flux Operator very, very easy. So we kind of worked on the user experience of that part of the story. So we have this new API called Flux instance that is the thing that allows you to move away from Git. Like, maybe to feel like strange to say that, but GitOps does not mean you need to run the Git server in your production system, or at times you don't want to depend on your hosted Git or your self-hosted Git or whatever you are using to be that single point of failure when you do anything in production. And how you can decouple Git from your production systems, especially around continuous delivery if you use Flux, is through OCI artifacts. So the idea is you still use Git and for collaboration, for change management, for history, for control, but Flux no longer goes and looks at your Git repo. And you can run in your CI a simple command called Flux push. So the Flux CLI has, like Docker, commands for interacting with a container registry. You modify something in Git, you do a commit, a push, and then you run Flux push that stores the state. Maybe you could sign it, so Flux can verify that artifact. So you store that state in a container registry. So then if Git goes down and you want to roll back or something, you can just act on the tags of an image, of an OCI image, right? You can still do rollbacks, you can still change your system even if Git is temporarily down. Another great use case for using OCI as the desired state is when you run in air-gapped environments. Flux Operator was one of the first adopters of the tool. As soon as we launched OCI support for it, were organizations that had these, they are highly regulated, they must run in an air-gapped environment, even if it's in a cloud, it's still, kind of air-gapped, I don't know, cloud air-gapped. Doesn't quite sound right, but anyway, you know what I'm talking about if you work in that, in those organizations. Another thing that we wanted to improve was automatic upgrades. Flux is mature enough. We have proved our users in the last year that we really care about backwards compatibility, and we even today you can upgrade from Flux 0 point something to the latest version, and it will work. So based on this, we said we need to make automatically upgrades better. How are you going to secure your systems if you are keeping them up to date? If your system is very old, a CV somewhere, it will affect you. Like, it's imminent. There is no doubt about it. The longer you run something in your infrastructure, and Flux runs as critical infrastructure, is cluster admin, is the first thing you deploy after you create your cluster, so it's like really sensitive. Anything there can actually affect and take control of your whole cluster. So what's the solution to this? You should always keep up with the latest release. And Flux Operator makes this very simple. You have their spec distribution version, you give it a semver expression, and that's it, and you forget about it. And Flux Operator will keep Flux up to date. And I have here 2 examples on how you can enable persistent storage for Flux internal artifacts, multi-tenancy, all the things that you can do with the CLI. There is no issue. You have a bunch of flags. You also need some customized overlays on the Git side. So instead of doing all of that, here you replace tens of thousands of YAMLs that you store in your repo as the Flux system. Here you just have this, couple of lines of configuration, and you can change it. You can enable sharding, disable sharding, upgrade, downgrade, and the Flux Operator will do the right things for you. Another goal for this was to reduce the chance of suicide. Like, it's very easy to destroy your whole cluster if you delete something in the Flux system directory in your Git repo. There are various ways of Yeah, because Flux is so flexible, you can do whatever, including telling Flux, hey, please delete yourself, and the whole cluster. And with Flux Operator, it's actually hard to do it. Really hard. It requires a lot of, you need to try really hard to be able to do that kind of stuff. So, yes, it also adds some guardrails, right? We want to better protect our users, especially because with Flux Operator, you'll be running fully automated. It's like GitOps on autopilot mode. So an autopilot should also be defensible, right? It should also protect you from doing bad things. Okay, so that was the first API we started with, making Flux easier to install, running it at scale, being simple to configure it. And we got to a point where we said we want to build high-level APIs on top of Flux, which don't actually make sense to build them to extend the current Flux APIs. There was a lot of requests, for example, for a Flux Helm release to be able to deploy from a pull request and stuff like that. Are we going to modify the Helm release API, which should be a reflection of what Helm does, and talk to what is a pull request? It's not even a Git concept. It's a GitHub concept. GitLab has merge requests, right? So, and Flux talks Git. It doesn't talk GitHub, GitLab, and so on. So, with Flux Operator and this new API, we kind of said, okay, we can add here the fancy things that are very scoped to whatever service you are running. And the goal of the resource set API is to give you this self-service environments feature where, yeah, self-service can mean many things to many people. And in the spirit of Flux, we didn't want to have the resource set API being highly opinionated. So we don't impose you the idea what an ephemeral environment means for you. In this case, an ephemeral environment means you create a new Helm release in an existing namespace. Every time someone opens a pull request, add a label. With the input provider, you tell Flux Operator, hey, scan this repo, watch for pull requests that have a label. And with the resource set, you tell it, create a Helm release object for each pull request that has a label, and use the git SHA of the pull request as the image tag, right? So you can change code, you can change configuration in a pull request. You open a pull request, your CI builds the image, and then you can deploy both the code change in the container that's packaged in the container, but also the configuration change, which is packaged in the Helm chart. And this example is, it implies that you have a preview server, you have a namespace there for each app, and you deploy there using Helm all the instances for every pull request, and it follows the pull request and so on. But this may not work for everybody. Some people may want to create a new cluster. How would you do that? You would add here in the resource set a cluster API definition. And then the Helm release will have the target to that cluster. So it's up to you. Or you add, I don't know, CrossPlane definition that creates the cluster and so on. So it's not, it does not forces you into telling you how you do ephemeral environments. It gives you the tool to build that stuff. And if you want, you can also create a namespace per pull request, or a cluster, or a Helm release, or no Helm at all, and you only work with Flux customization and so on. So yeah, it's I'm quite excited about this new way of doing, being able to test things before you merge them. I think it was one of the most high requested feature in Flux. Like, people are saying, I don't want to merge, I don't want to see it running on a cluster. So yeah, we finally have this capability. So please give it a try. Tell us how it went. Still early days. We want to improve things. We want to expand it more. It only works with GitHub and GitLab for now. if you have other Git services, open an issue, maybe contribute. Yeah, so that was the Flux Operator. How much time?
I think we have like 30 seconds. We can
speed
run through this.
Okay. So to end, these are the things that we've shipped in Flux 2.5, the latest release. For many of you running on GitHub, the request always was, we want app authentication. We don't want to link Flux to a personal access token. One of the Flux maintainers, Deepti, she works at Azure Arc, and she contributes a lot to Flux. She helps us, with Flux maintenance. She actually implemented GitHub authentication, and yeah, give it a try. If you are on GitHub, now you can decouple Flux from personal access tokens. Another thing that we've been working on, and this is a long-term request, are having a way to define custom health checks with common expression languages. So now we can do that with Flux, and it works with cross-plane, it works with cluster API. You can do many advanced things when you deal with Flux dependencies, when you say, I want first to create the cluster, then some other things, I want to check those other things are there. So now you have an expression language, which is very cool. It's been integrated in Kubernetes. It's part of the policy agent, the built-in policy agent, and we are working on getting more integrations with Cell in Flux. We think this is the future of the Flux APIs. If you want to extend Flux in some way, we will be trying it to do it using Cell, which is quite powerful and more flexible. That add hundreds of fields to the APIs. We kind of think Cell will work really great in the future for us. Yeah, and we also completed the OCI part of Flux. So you have notification controller which can go into Git and say, check, this commit was successfully reconciled on the cluster. But if you use OCI as an intermediate layer, we couldn't do that. And now we can. We can with metadata. So even if you use a container registry as the desired state, Flux can go back and say, even if it was reconciled from a container registry, and go back to Git and say, yes, this commit was completed successfully, or it has error out. Yeah, please check out our roadmap. There are many things coming this year. We are highly focusing on features. Yeah, that was it. Thank you very much for being with us.
Thank you.